Good morning or good afternoon again, depending on what time of the day you're watching this. And welcome to another episode where we deal into or delve into working with large models in SUMO. And this will be part two of just discussing our meshing issues or just meshing workflows in SUMO when we have very, very large models or just large models in general. So let's jump into it. So the last time we dealt with slab cutouts, and you can you can watch part two as well. I think it'll be very helpful. And today we're going to deal with if we have walls or plain shells that connect into our slab. And so one of the things that we always want to do is we want to model as accurately as possible. All right, and already when we get to an analytical package, that becomes incredibly difficult because of how it works. Everything works on centralized planes, shear centers, and center lines. All right, and in reality, we don't necessarily, our buildings aren't modeled like that if you think of how you'd model in Revit, etc. So here we've got a wall, and this wall extends beyond the slab, so it's a 3.3 meter high wall. The slab center sits at 3 meters. And we have this little ledge or lip here so that people can't kick stuff off, or we're going to fit a balustrade onto that, or whatever it might be. Now, when you mesh, you're going to have some problems. So if I go to my discretized model view, although it looks neat, we'll most likely pick up some problems because of what's happening with the meshing up here. Okay, you can have that some of the shell elements have a zero length, etc., etc. And as you can see here, so at the moment, this mesh size is 1 meter. This mesh size is 0.5. So what we want to do is first we want to have our wall should have at least the same mesh size as our slab. Okay, this is just based on best practice. This is not telling you this is what you have to do, but I just think that this is best practice. And we can see that there's just something funny happening with the mesh in general. So you have got two options. So either you reduce this wall height to the height of the slab. Just mesh again, and you see that it's much better, and it'll be this slab or this edge will be a lot more stable because the slab does connect into that element. Or you extend it a bit more so that it extends the height of the mesh above the slab, and that will be 3.5. And again, this doesn't look fantastic, but it will be more stable along that edge. And the same if you have walls coming through the center of the slab or anywhere else here, do you want to approach it the same way? Okay, so in general, I know that we don't want to have less material represented on our model because we're concerned about the self-weight component. And with that, you can maybe even create an area load that compensates for that, or just assign an additional live load there for whatever you've removed. So you know that you're removing 0.3 meters of that wall, you know the thickness, you know the density, and then you can assign a line load on that edge. So if we reduce this to 3, we can go to loads, we can go line, and we can just assign a line load in there to compensate for the self-weight we've removed here. Okay, it will still it will still contribute its stiffness to that edge. And of course, this isn't the beginning and end all of how we think about this, but this is just a good indication or a good workflow to ensure that you have a stable mesh in your model, and that when you start running your analysis, that you actually don't run into trouble. Okay, if you guys have any questions or anything in particular, any suggestions or concerns, please pop them in the comments. I'll definitely have a look at them at some stage, and I can even create a follow-up clip where we discuss some of the comments and concerns that people have, or even suggestions. So thank you so much for tuning in. Hope that you have a fantastic day, and looking forward to seeing you in future videos.